Hi, grade ninths. As mentioned, we have to be very careful and move very methodically and at a slow enough pace that we don't overlook anything when we're dealing with the surface area of objects and composite objects. So I'm going to break this into two videos, and I strongly suggest that you sort of take your time going through the video and sketching out the examples in your workbook or on another piece of paper, just to make sure that you understand everything completely and that we're being very accurate with which sides of the object that we actually have to paint, because some of the objects are quite complex. So I just thought these are neat houses in the Netherlands. They're built like cubes. They look pretty cool, and they've got some overlapping there. So you got to think about you've got to think about which parts of the house you don't have to paint and which parts of the house you do have to paint or put shingles on or whatnot. So that's what this unit's all about, really, is how much paint do we need to cover these objects. So let's start here. These are these internet-connected cubes are a math manipulative, and they're very handy in a physical math class because you can click them together and you can make all sorts of different shapes, and you can turn them around in your hands if you're one of those people kind of like me who needs a very visual example. Unfortunately, there isn't really a great way of doing this digitally, and I couldn't find anything that was particularly useful on any of the math websites. So I'm going to recommend that if you have the opportunity to maybe pick some of these up at a teacher store, or maybe Amazon, or you could just glue some, or not glue, definitely don't glue. Maybe use some masking tape to tape some dice together if you need to turn objects around in front of you to help you understand it. I'd recommend doing that. So we're just going to have to try and do the best we can, working from the pictures that we have. Okay, so terminology: right rectangular prisms. Okay, a prism is really just any shape that's got flat sides. So there's not going to be, there's not going to be any curvy sections or 3D sections that are curved. They're mostly going to be flat. Now they could be circular or rectangular or triangular or any other shape really, but they're going to be flat. So that's the important part about a rectangular prism. Or rectangular means just they're going to be either squares or rectangles. So if we look at the first set of cubes there, it's all squares. Okay, the final object might not be a square, but it's made up of all squares and rectangles. In this case, just squares. So there are two strategies for determining the surface area or how much of this object we actually would need to paint. Okay, these unit cubes here, each face is exactly 1 centimeter. So if we do length times width, that means 1 centimeter squared. All right, so 1 centimeter squared for each of the faces that you can see. And we're going to need to keep that in mind when we do our examples. So here's a couple strategies for determining the surface area. All right, this is the exact same object. It's just kind of drawn somewhat transparently so you can see through it. If we're going to put paint on this guy, one thing we need to notice is that we don't have to put paint there or there or there on the inside of that block, right? They're together, so they're kind of covering up faces. And what we need to do is we need to find a way to take those faces out of our calculation so we don't buy too much paint. So the first way that we're going to talk about is counting and then subtracting. So what we're going to do is we're going to count the square faces of all the cubes and then subtract 2 for every cube that's connected. Because if they're connected, it's not just one place, or it's not just one side that we don't need to paint. Because they're together and it's 2 different cubes, there's actually 2 sides in there we don't need to paint. Each wall is two cubes connected. So here's how I would tackle this one here. First off, let's just count the cubes. If there were no interlocking sections, how much surface area is there? We've got 1, 2, 3, 4 cubes. All right, so there's 4 cubes. I don't know why I'm using my mouse here. I should be using this. 4 cubes. And how many sides does each cube have? Well, just think of a cube as dice, a die. There's 1, 2, 3, 4, 5, 6 numbers, so 6 sides on every die. So if there was no interlocking or overlapping at all, we would have 4 cubes times 6, I should probably write sides per cube up there, which would give us a total of 24 sides. Right, now remember, each side is just 1 centimeter squared, but let's just worry about sides for now. Now we have to subtract from that, okay, how many overlapping sections do we have? we've got this side on the inside here. Remember, we're looking on the inside right now. We've got this side here, and we've got this one here. So we've got 3 sides that overlap or interlock. So if we've got those 3 interlocking sides, remember we always multiply by 2 because it's 2 put together. So 3 times 2 equals 6. So that's what we have to subtract. So if we go 24 minus 18, and I'll just call these, what should I call these? I'll just call these the overlap because that's the term we probably should be using. And we're left with 18. Ooh, here goes my pen again. Crazy pen. Crazy Dunbar. So that leaves us with 18 sides we need to paint. And in this case, each cube is 1 centimeter squared. Each face is 1 centimeter squared. So it's really, if we were using a measurement, it would be 18 centimeters squared. And what that is the surface area. That's the whole unit right now. We're dealing with surface area, or what we have to paint. So that's one way. And some people find that way easiest to do. The important part on that one, though, is you really need to kind of draw yourself a decent diagram or have something that you can turn around in your hand. The other way, the way that I like to use, because it's typically the way that the method that we'd use with more complex objects anyway, is you try to draw each side of the object. So in drawing each side of the object, you're less likely to forget the back or forget that there's 2 overlapping spaces or whatnot. So this one, you also have to kind of be able to look at the object in your mind or have something in front of you, whether it be a picture on the screen or maybe some dice that you've got sitting there to decide, what can I see? And you have to look at it in each direction. So I've just got an eraser here right now. Let's say, for the sake of argument, that I had to find the surface area of this. I'd want to make sure that I would look at this and say, I've got that side, and then I turn it, and I got that side. And what does this thing look like from the top? So I've got to turn it to the top. And in this case, the bottom's the same as the top, and this side's the same as this side, and this side is the same as this side. And if you look at our diagram, the same thing plays out there, right? So if you notice, the top looks exactly the same as the bottom, just pointing a different direction. The front looks the same as the back, except on the back you can see you can just see the lines where they're interconnected, but it doesn't matter. And the left side is really the same as the right side. So you only have to really figure out one of the sides and then multiply it by 2 to make sure you get the other one. So in this one, there's 4 squares on top. So there's 1, 2, 1, 2, 3, 4. And there's also 4 squares on the bottom. So that's easy. 1, 2, 3, 4. There's 3 squares on the front. 1, 2, 3. There's 3 squares on the back. 1, 2, 3. There's 2 squares on both the left and the right. So if we add all those squares up together, we've already taken into account all of the overlapping, because anything that's overlapped we won't be able to see because it's going to be on the inside of the object. So in this case, we don't have to subtract anything. We just add them all up, and it's going to be 18. Okay, so you can write surface area equals 18. In this case, let's just call it centimeters squared. But instead of writing out surface area every time, why don't you just write out S dot A equals 18 centimeters squared. It'll just save you some time in writing. Okay, an object that's made up of other objects or composed of other objects is called a composite. Object. Sorry, I had to write really small there. This is an M, not an N. M. Okay, it's a composite object, and the more objects that are jammed together, typically the more difficult it is for us to find out how much surface area there is. Okay, now determine the surface area of this composite object. Okay, obviously it's lots of these little blocks put together, so let's just use both of those methods and see what we get. So this is the object represented so that we can see inside. And let's just look at how many overlapping spaces we have. We've got that overlap, we've got this overlap, we've got that overlap, not on the front and not on the back. So yeah, we do have an overlap there. Okay, so again, this would be easier if you sort of had the cubes to play around with. But let's see what we got here. Okay, so using the counting method, or actually, I'll just say method 1, which is actually the subtraction method. Okay, so doing it, the first way, method 1. What we needed to do is count all the cubes total. So I'm just going to write total equals how many cubes are there? Okay, I'm going to go back and have another quick look at this object just so I make sure. Okay, so 1, 2, 3, 4. Okay, 1, 2, 3, 4, and there must be a cube under there too, so that's 5. And I don't think there's a cube sticking out the back, but again, there might be. No, there isn't a cube sticking out the back. This blue cube is actually on the inside, right behind that orange one. Okay, so we've got 5 cubes, okay? So 5 cubes times 6 sides per cube, which is going to give us a total of 30. Okay? Now what do we subtract? So let's look at our overlap. So our overlap, our overlap here is we're going to have this face overlapped. We're going to have this face overlapped. We are going to have the top of that blue object overlapped and this side overlapped. Did I get them all? Okay, just pretending there's a blue cube in the middle of all these. We've got the top overlapped. We've got the side over here overlapped. We've got the front overlapped, and we've got this side overlapped. Okay, which really only leaves us the block on the bottom. So if we look at this thing from underneath, we'll be able to see the blue block on the bottom because that's not covered up. And if we look at it from the very back, we'll be able to see that blue one as well. So how many overlaps did I say there was? I already forgot. Okay, there is the front, 1, side, 2. The top of the blue cube is 3, and this side is 4. So there's 4 of the 6 sides. Okay, 4 of the 6 sides overlap. So now all we've got to do is surface area is going to equal the 30 total, minus 4, and don't forget this, times 2, because when a block hits another block, it's actually 2 sides that come together. All right, so it's 30 minus 8 equals 22, and we'll call it centimeters squared because we're using centimeter blocks. So there's 22 centimeters squared using method 1, which is find the total and then subtract the overlap. Method 2, which again I kind of prefer. I think it keeps me a little bit more organized, and I'm less likely to make mistakes. So we've drawn out the object very carefully to make sure that we include every side. So let's look at the top. Okay, and I'm gonna put the. Can you see everything the same on this one? You know what? I'm gonna separate them out. Okay, so here's the top. We've got 1, 2, 3, 4. Okay, so 4 sides. Okay, let's look at the bottom. Probably the same. 1, 2, 3, 4. Okay. Let's look at the left side. I'm just going to put LS. 1, 2, 3. And the right side is also 3. So left side is 3. Right side is 3. Okay. And what did we miss? Oh, we missed the back. We missed the front and the back. Yeah. Front. So this is the front. 1, 2, 3, 4. And the back is also going to be 1, 2, 3, 4. Let's add them all up. See what we got. So that's 8, 11, 14, 18, 22. We got the exact same answer, which is a good thing. That means we more than likely got it right. So the surface area, I'm just going to go S8 to save us writing, equals 22 centimeters and squared. Okay, surface area is always squared. I'm going to go back and check and make sure I put squared on the other one. Yeah, surface area is always squared. Okay. Let's move on. Okay, now we've just got a block. These ones are actually a little simpler. I like to keep us moving and make sure that you got a little practice figuring out. There's no overlapping on these. So this is just straight find the surface area of, in this case, a cube. All right, so if we look at this cube, okay, let's just do it the simple way. How many sides are on this cube? There are 6 sides. Okay, each side has a surface area of, okay, we got to find it out because this time we're not using centimeter blocks, so it's actually got different units. All right, now this is a cube. We can tell it's a cube because the length, okay, the width, and the height are all the same. So if it's a rectangular prism, okay, and it's a square on all sides, that actually makes it a cube. If it's a cube, that's really handy because every side has the exact same surface area. So each side has a surface area of, well, how do you figure out the surface area of a square? Okay, let's just look at the front side for now. It's just length times width, okay? So area equals length times width, but it's also a square. They're the same. So you could also say area equals the side squared. So, you could call any one of these S for side. Or you can call this one length and this one width or something like that. Okay? So you need to use this if it's a rectangle, and you need to use this if it's a square, or you can use this as a square. You should get the same answer both times if it's a square. So the area is going to equal, what did we say, 3 squared equals 9, okay? Each side, so I'll just put one side here. Okay, the area equals 9, meters squared, okay? Now, I'm just going to draw an arrow, because I don't know if I'll have enough room there. Total surface area, okay, equals 6 sides, okay? There's 6 sides, front, back, top, bottom, left, right, times, and each one of those sides is 9 meters squared, okay? 9 times 6 is 54 meters squared. So that is this total surface area, right, SA, of this cube. Now, let's do one more. This one, slightly different, still all rectangles, okay? Rectangles, and yeah, there's no squares on this one. So this is one where I would strongly recommend that you actually draw out the sides so that you don't miss one. Okay, so here's all the sides. All right. If I look at this object, okay, and diagramming here what each measurement is, that's really important as well. So if I look at these measurements, if it's 6 here, it's also, whoop, yoink. Oh no. I'm gonna make that a little bigger now. Okay, get back to my pen. If this object is 6 on this side, that also means it's 6 here, and it's 6 there, and it's 6 there. Okay, you may want to label it once, you may want to label it more than once. So that means this one's 8, this one's 8, this one's 8, this one is 12, so all these long ones are 12. Right, I also sometimes just put numbers in them so that I don't forget one. So maybe I'd call this one number 1, and this one is kind of the same, so it's number 2. Maybe I'd call this one number 3, this one number 4, and let's call this one number 5, and this one number 6. I've circled those numbers so I don't get them confused with the measurements. Okay, so for side 1, okay, side 1 is 8 by 12. It's a rectangle, so the surface area equals 8 centimeters times 12 centimeters, all right, which is 96 centimeters squared. So I took care of number 1. Number 2 is the exact same thing, okay? Same as number 1. So I could do the math again, but why would I? Okay, so number 3 is, this one is 6, and this one is 12 down here, right? All the long ones are 12. So the surface area of number 3 is going to be, what did I say, 6 centimeters times 12 centimeters, okay? And 6 centimeters times 12 centimeters is 70 centimeters squared. Again, if you're good at math in your head, it's good practice to do it in your head. I'm not always so great at mental math. If you need a calculator, if it really helps you out to use a calculator and that makes you less anxious, that's fine. You can use a calculator. Number 4 is, I believe, the exact same as number 3. Okay? I might actually write the numbers here so I don't forget them. There's 96, and this one is 70. Okay, so that leaves us 2 more, right? What's number 5? Number 5 is 6. Oh, what's this right here? Okay, what's this right here? We haven't noted what that is, but if we think about folding this up, straight up, into a box, so it's right now it's lying down, let's fold it up. It has to meet this one when it folds up too. So if that one comes together with it, okay, if that one comes together with it, it must mean that this is the exact same as that. All right? So this would also be 8, as well as, you know, this part over here. 8. Okay? So for number 5, we've got 6 by 8. So SA equals 6 centimeters times 8 centimeters. Okay? And that equals 48 centimeters squared. And guess what? Number 6 on the right side is exactly the same. Same as number 5, which is 48 centimeters squared. Now let's put it all together, okay? So at the very end, the whole goal of doing all that, and you notice how I separated it out into 6 shapes, and I took my time with each of the sides to make sure I didn't make any mistakes. So the total surface area is going to be equal to all of those together. So 96 plus 96 plus 70 plus 70. I didn't make a mistake there. Ooh, I made a mistake. Dunbar, what are you doing? 6 times 12 is not 70. Oh, good grief. See, I always leave my mistakes in because it shows that we all make them, okay? But checking over your work will help you catch most of them. I bet a bunch of you earlier in the video were going, that's not 70, what are you doing, Dunbar? Okay, so like I said, I'm not always that great with mental math. Let's try again, and I'm just going to be sure of myself, so I'm going to multiply that. That's a 2, so 6 times 2 is 12, and that's 7. Oh, 72. Why didn't I just say that the first time? Oh, good grief. Okay, so that's 72 centimeters squared. Okay. Oh, by the way, if I ever make a mistake in these videos and I don't correct it, oh, please let me know, because that shows me, A, you're paying attention, and B, I need to redo that video and fix it. So these are both 72 centimeters squared, centimeters squared, centimeters squared, centimeters squared. What have we got left here? 48. I better check my math. 8 times 6, yeah, that's 48. Okay, so 48 centimeters squared and 48 centimeters squared. I'm just going to extend my page a little bit. And we have to add that, right? Adding each side together will give us the outside. Oh, good grief. I could do that on paper, but you know what? I'm just going to plug it into my calculator because I don't want to make any more mistakes, especially at this point where I'm coming up with the final answer. And what I get is 432. Somebody check the math on that just to be sure. Okay, so my total surface area, surface area equals, what did I say? 432. 432 centimeters squared. And I always ask myself after, is the answer I got reasonable based on the numbers I used? Well, let's see, it's about 100, 200, 350, 4. Yeah, that's about right. So it looks like this is a reasonable number, and I think it's correct. Okay, now we're moving away from prisms. This is going to be the second video. I just want to quickly introduce it. When we're thinking about composite shapes, it doesn't necessarily have to be squares and rectangles. Now, I said before that it can't have curved sides. I was just talking about rectangular prisms. In fact, composite objects can have curved sides because we do have formulas to figure out the surface area of spheres and things like that. So you will see some of those, but 90% of the time, you're going to see prisms, just flat sides. So here's some other composite shapes. This is a cone. And on top of the cone is about half of a sphere. Okay, sphere being a ball. All right, you've seen an ice cream cone before. Oh, look at this one here. Whew. That looks like it's just a whole bunch of rectangles on the bottom stacked together in all sorts of weird shapes. And then there's some like triangular at the top, but it's composed of different shapes, right? Different types of blocks. If we look at this one, we've got sort of a what I would call a rectilinear prism on the bottom because it's just a box made of rectangles. Think of it like a shoebox. And then on the top, we've got a triangular prism, okay, where we've got a triangle on the front and the triangle on the very back. You just got to think about having a line right here to separate the triangle from the rectangle. So there's a triangle at the front, there's another triangle at the back, and then we've got more rectangles on the sides. So you can make up all sorts of different composite objects depending on the kind of shapes you want to use. But we have to still be able to figure out the surface area so we can put paint on it or carpet on it or roofing on it or whatever. So that's going to be the next video. But I suggest that you maybe look at your workbook and try a couple of those questions out. Check the text, try a couple of the easier ones out to find surface area before you move on to the more complex composite objects. That'll be the next video. Good luck.